This is 11.6, and it's just going to be a review of the factoring that we've already learned. So here we're going to draw the box. We're going to put in x squared and 18. Multiply those together. 18x squared. And then we factor 18. 1 and 18. 2 and 9. 3 and 6. 4 and 5 don't work. And we want two numbers that multiply to be 18, which means these factors are either plus plus or minus minus, and they need to add to be -9, which means they're both minus, and we need to choose the pair that add to be -9. So that would be -3 and -6. So we put -3x in one of the boxes and -6x in the other. What do these have in common? An x. So we remove an x, and if I take an x out of here, I have an x left over. If I take an x out of there, I have a -3. And if I take an x out of here, I get -6. And it's always a good idea to check, is this number times this number equal to 18? Yeah. So my factors are x minus 3 and x minus 6. Same idea here. So 7y squared and -2. Multiply those together, and I get -14y squared. And because this is negative, I know that the factors are either plus, minus, or minus, plus. The factors of 14 are 1 and 14, 2 and 7. 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work. And when I add those two together, I end up with a -5, which means that the bigger number is negative. So it would be plus, minus, like this. Will one of those sets give me a -5? Yes, this one. So -7y and 2y. Okay, what do these have in common? They share a 7 and a y. And if I pull out a 7 and a y, then I'm left with y minus 1. And if I remove a y from the first column, I'm left with a plus 2. And then double check, is this number times this number equal to that number? Yeah. So my factors are y minus 1 and 7y plus 2. All right. Thanks. So draw the box. 5x squared and 18. So 5 times 18 is going to be 50 plus 40 is 90. 90x squared. The factors will be 1 and 90, 2 and 45, 3 and 30, 4 doesn't work, 5 and 18, 6 and 15, 7 doesn't work, 8 doesn't work, 9 and 10. And this number is positive, which means my factors are either plus plus or minus minus. And this is negative, which means both signs are negative. Can I use one of those sets to create a -33? Yeah, this one. So 3x, -3x, and -30x. What does the top row share? An x. If I pull an x out of the top row, I'm left with 5x plus 3. And if I pull a 5x out of the first column, I'm left with -6. And then double check. Is -6 times 3 equal to 18. Oh, nope, it's not, because this should be a minus 3. So is negative 6 times negative 3 18? Yeah. So my factors are 5x minus 3 and x minus 6. All right. This one looks kind of scary because we have x's and y's, but it follows the exact same pattern. I stick in my x squared, and I stick in my 20y squared. When I multiply those together, I get 20x squared y squared. I factor 20, 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. And because this is positive, I know that my factors are either plus plus or minus minus. And I'm looking for two numbers that multiply to be 20 and add to be negative 12. Well, if these were negative, that would work. But when we multiply the 2 and the 10 together, they have to be 20x squared y. So they both get an xy. So negative 2xy and negative 10xy. Here I can pull out an x, and that leaves me with x minus 2y. And if I remove an x from this column, I'm left with negative 10y. And then we double check, is negative 10y times negative 2y equal to 20y squared? Yeah. The end result is going to be x minus 2y and x minus 10y. Okay. So 15z squared and 18. Well, I don't know what that one is. 15 times 18 is 270. This is positive, so it's either plus plus or minus minus. And that one's positive, so they're both going to be plus. So 270 is 1 and 270, 2 and 135, 3 and 90, 4 doesn't work, 5, I don't know, 270 divided by 5 is 54. 6 and 45. 7 doesn't work. 8 doesn't work. 9 and 30. 10 and 27. That's the one we want. So we want to add to be 37, 10, and 27. So 10z, 27z. The top row shares a 5 and a z. So if I take a 5 and a z out of those, I'm left with 3z plus 2. If I take a 3z out of this, I'm left with 9. So my factors are 3z plus 2 and 5z plus 9. Okay. Look at this one. Something happens in this problem that hasn't happened before. All of these are divisible by 3. So we need to pull a 3 out. So I take a 3 out of that, and I'm left with b squared. I take a 3 out of that, which gives me 17. and I take a 3 out of that, which gives me 30. So every time you factor a quadratic, you need to check to see, can we pull anything out? Now that 3 is still part of my solution, so I'm just going to hang on to it until the end. For the rest of it, I draw the box, v squared 30, so 30v squared, and my factors are 1 and 30, 2 and 15, that's the one I want. I want to add to 17, so 2v and 15v. The top row shares a v. If I remove a v, I'm left with v plus 2. The first column shares a v, so I pull that v out and I get plus 15. And don't forget that the 3 is part of your solution. So the factors are 3, v plus 2, and v plus 15. Oh. Okay. Oh, we don't want to do that one. Sorry. So here, I can't take the 7 out, but I haven't taught you how to factor if the leading coefficient is negative. And I could teach it to you, but it's easier just to pull it out. So anytime the leading coefficient is negative, we're just going to pull out that negative, essentially a negative 1. So if I remove a negative from all of those, then I have the opposite of, and every sign is going to change. So 7x squared plus 12x minus 4. It just changed the sign of all of those. And now in the box, we have 7x squared and negative 4. Multiply those together, and I get negative 28x squared. And I'm looking for a 12. So 1 and 28, 2 and 14, and that's it. Negative 2 and positive 14. So 14x and negative 2x. What does the top row share? A 7 and an x. If I pull out a 7 and an x, then I get x plus 2. And then I take an x out of this last box, and I get negative 2. And don't forget, this is still part of our answer. So negative x plus 2 times 7x minus 2. And that's it. Get to work.